Welcome to qnawire.
So for part A, we want to find the total distance it takes for the car to stop. So we know that the final velocity of the car is 0. So we can say that velocity final squared equals velocity initial squared plus 2 times a delta x. We are solving for delta x, so delta x, the change in displacement in the x direction, would be equal to velocity final squared minus velocity initial squared divided by 2 times the acceleration. We know that the car is coming to a stop, so this can be considered negative, or rather, this can be considered 0. And so we can say that this is going to be equal to negative times 85 kilometers per hour. We're going to use a conversion, so 1 meters per second for every 3.6 kilometers per hour. And then this quantity would be squared. And then this would be divided by 2 times negative 0.50 meters per second squared. And we find that delta x is going to be equal to approximately 557 meters. For part B, we want to find the time to stop. So we can say that velocity final equals velocity initial plus at. We know that the final velocity is 0. So we can say that the time taken would simply be equal to the negative 1 times the velocity initial divided by the acceleration. So this would be equal to negative, again, 85 kilometers per hour multiplied by 1 meter per second for every 3.6 kilometers per hour. And this is going to be divided by a, so this would be negative 0.50 meters per second squared, and we find that t is going to be equal to 47.2 seconds. So this would be your answer for B. The time it takes to stop, the total distance traveled when it's trying to stop, and then for part C, they want the distance traveled in the first second and the 5th second. So for part C, we can say that x initial would be equal to x at t equals 0 seconds, which of course would be 0 meters. And we can say that again, a is going to equal negative 0.50 meters per second squared. And we're going, again, the initial velocity is 85 kilometers. So we can say that for x in the first second, this would be equal to 0 plus 85 kilometers per hour multiplied by 1 meter per second divided by 3.6 kilometers per hour multiplied by 1 second plus 1/2 times negative 0.50 meters per second squared multiplied by 1 second quantity squared. And we find that traveled in the first second would be equal to 23.4 meters. Now, we need to find the total distance traveled in the 5th second. So we can say that we need to find x at t equals 4 seconds and x at t equals 5 seconds and subtract the two values. So let's get a new workbook. Again, x at t equals 4 seconds. This would be equal to, again, 85 kilometers per hour. We know that the initial position is 0, so we have 1 meter per second divided by 3.6 kilometers per hour, multiplied by 4 seconds, and then plus 1/2 times negative 0.50 meters per second squared, multiplied by 4 seconds quantity squared. This is going to be equal to 90.44 meters. Don't round until the very end. And then x at t equals 5 seconds would be equal to 85 kilometers per hour multiplied at 1 meters per second divided by 3.6 kilometers per hour multiplied by 5 seconds, and then plus 1/2 times negative 0.50 meters per second squared times 5 seconds quantity squared. And this is going to equal 111.81 meters. And we find that x at 5 seconds minus x at 4 seconds is going to equal 111.81 minus 90.44. And the distance traveled in that 5th second would be equal to 21.4 meters. That is the end of the solution. Thank you for watching.